All right, guys. Today we're going to spend a little bit of time talking about piecewise functions and what piecewise functions are. And you may be kind of a little confused at this point as to why is there this little cartoon of a Frankenstein hanging out on here. But I hope that this example will make sense here in just a minute. But piecewise functions are essentially the Frankenstein of the mathematical world. And if we think about the actual, Frankenstein monster, and if you've read Mary Shelley, or what is her name? If you read the book Frankenstein, essentially what the Frankenstein monster is some sort of monster that's been made up of parts of different human beings, right? The Dr. Frankenstein went and dug up these, various graves, and then he'd take a hand from one grave, and then maybe the foot from another, and then the rest of the arm from a third one, and so on and so forth. And then in collecting all these body parts, which is kind of gross and kind of weird to think about, but in collecting all these body parts, then reattach them together to make one whole thing, right? In this case, the Frankenstein monster. And so these piecewise functions are kind of the same thing. What we're gonna have is pieces of various functions that are gonna combine together to make one function. And if we think about the actual word piecewise, right? I mean, we've got right in there the word piece, right? Piecewise functions. And in other words, again, we're saying that these are pieces of functions that are going to combine together to make a whole. Okay, and hopefully that idea, at least in theory, makes some sense to you guys. Okay, so let's take a look at what that's going to look like. Okay, so what we have right here, guys. Is an example of a piecewise function, and I did this so that we could see each one of these pieces actually in separate colors to hopefully make this a little bit easier to identify these various pieces. The shape that we have here, there's really no one function without being a tremendous pain to deal with that's going to kind of express this overall thing here. And so just to go through this, let's identify these pieces first. Our first piece is going to be this one right here, this blue stuff, right? Our second one is going to be this horizontal line right there. The next one we've got is our this purple piece. We've got another horizontal line connected to that, and then our last piece here is going to be this long red one. Okay, so hopefully that's easy to identify those pieces, guys. And you may be wondering, can they only be linear pieces? Well, no, they can be all sorts of different things. In this example, I've only got a linear or linear pieces, but they could be all sorts of different functions that are going to combine to make these. So could you potentially have a quadratic function and a linear function and an exponential function all in one piece? Yeah, or all in one piecewise function? Yeah, you absolutely could. But in this example, we're just going to do linear functions just to make this a little bit of an easier process as we begin to explain how to understand these. So just like in this example that we talked about with Frankenstein, right, where Frankenstein's monster is literally made out of these pieces of different functions. You can imagine Dr. Frankenstein is literally there. He's got these, and he's cataloging all these different parts that he's putting in or onto the monster in order to, because he's a scientist, and in order to track his experiment and understand what's happening and what could potentially go wrong. So the first thing we need to do here is identify these different parts and what they are. So our blue one here, we can see is a linear function, and if you remember, linear functions are going to have an equation that looks like y equals mx plus b. And this will hold true for all the ones that we've got right here because this is just going to be, they're all linear pieces. Where our m, remember, is the slope or the rate of change, right? And our b value here is going to be the y-intercept. And so for at least for this first one here, this is going to be a pretty easy one to write the equation of, right? And I will just say this, as we deal with piecewise functions, it might also be useful to know or to review one of the other forms of linear functions, which was our slope our point slope form, which is where if you have the slope of the equation and you know a point that it goes through, you can write the equation. There's nothing saying in piecewise functions that you have to express linear functions in one form or another, so you can write it in any one that you want. And that's going to be the point slope form is going to be y minus y1 equals m times x minus x1. And this one right here again, guys, is going to be especially useful when we're dealing with these piecewise functions, because we can see right here that I've got this one and I can very clearly and easily identify the y-intercept. But for the rest of these linear pieces here, identifying that y-intercept might be a little tricky. Okay, and so we need to you know, or not need to, this would probably be the easier form to put that into. Alright, so let's go ahead and get into this, and let's just start writing our various equations. We got our first equation here, this blue piece right there, which we've, you know, it's going to be y equals mx plus b, where my m is going to be my slope, and we can address our slope here. We're going up 1 and over 1, and then up 1 and over 1, up 1, right? Well, I guess we don't do the 1 right there. But so we can see here that we've got the same measure of units for both sides. This is 10 and this is 10 there, meaning that each one of these units is 2. So we're going technically up 2 and over 2, or 2 over 2, which is the same thing as 1. 1 times, since it's a 1, we don't actually need to write it in. We just write that as x. Right, so I've got x, and then what is my y-intercept? Well, my y-intercept is 0, right? So I could put my plus 0 here, but adding 0 to this is the same thing as just, you know, saying y equals x. Y equals x plus 0 is the same as y equals x. So we don't need to put that in. We'll just say for our first function here, we've got y equals x. Okay? All right. Now, the next thing when we talk about this example of Frankenstein, right, is that it's important to mention what part of each corpse was Dr. Frankenstein using. He wasn't just saying, oh, I just use this body and this body and this body. He's saying, oh, I use the hand from this body and the arm from this body over there, and then the leg from that body, right? We've got to identify what part is being used, and so let's go ahead and do that really quickly. Well, what part of this function is being used? And we could identify that in a couple of different ways. We could identify it using our domain, but we could also identify it using our range. Most people are going to identify it using domain. That's just going to be the more consistent one, right? So we can go ahead and identify that domain. And I'm using this part from right here all the way over to this part right there. Okay, and hopefully that's making a little bit of sense here. Okay, hopefully that's making a little bit of sense. So I'm literally using this whole piece of it. Well, what is this piece? This piece is where is from 0, or in other words, when x is greater than or equal to 0, and when x is going to be less than, well, what's this point right here? Again, each one of these boxes is 2, so we've got 2.5, or in other words, 5, right? So and then all the way up to when x is less than or equal to 5, right? Okay, and we actually might not say less than or equal to, but up to 5, right? Well, let's just say up to 5. Okay, so this is the part of this function right here that we're using, and so we need to specify that as well, right? So let's go ahead and specify that. So I know that I'm using this function from 0 is less than x is less than 5. Now, or less than or equal to x. So we could express this in different notations, by the way, guys. If you wanted to just write this out as 0, parentheses 0, comma, oops, excuse me, that wouldn't be parentheses, it would be a bracket 0, comma 5, parentheses. Either one of those is an adequate way of expressing this function, right? So, don't worry about it. And what all that tells us is just like what we were talking about, is when Frankenstein digs up a corpse and he grabs a body, he says, okay, I'm going to use the up to the knee on this one, or whatever it is. You got to specify specifically what part you are dealing with. And in this case, the part that we are dealing with is this part from 0 to 5. Okay, hopefully that makes some sense. Let's keep going through this. Let's take a look at that green section next. And let's do that. So I'll just try and match these up. So this green section is a horizontal line, right? We notice that we're not going up at all, and hopefully you guys remember how to do this. But when we have a horizontal line, we're going to write that out as simply just whatever the y value is of this, right? And we can see what that y value is just by counting up. Again, each one of these is measure of 2, so I'm going 2, 4, and then 5, right? So this next equation is going to be simply just y equals 5. And whenever you have a horizontal line, just as a general reminder, guys, horizontal lines are always going to be y equals whatever the value is, and vertical lines are always going to be y or x equals whatever that value is. Okay. But we're not done yet, right? We need to specify when are we using this, right? When are we using this information? And we're using this information, well, where did we leave off? We left it off at 5, so we're using it from 5 less than or equal to x, and we're going all the way over to right here. Well, what value is that? That's 12, right? So I know that my part of this that I'm using is going to be from 5 all the way to 12, and we could write it in either notation, right? Again, we're going to have a bracket and 5 comma 12 parenthesis, right? So hopefully that's making some sort of sense for you guys, that we can clearly identify the piece right here as well as when we're using it, and we're using it from 5 to 12. Okay, let's go on to the next one. This next one, guys, keep in mind this is a great example of when we're going to want to be using this form over here, right? Because if I look at this, I notice I'm not going to necessarily see where this crosses the x-axis, and I guess I could, or the y-axis, excuse me, and I guess I could kind of like trace it backwards or whatever else, but I don't know where exactly that's going to be. So if it were me, I would just say let's start by identifying our slope, and to do this, I want to pick out 2 good points with nice intersections on the axis, or on the x and y lines there, and I've got one here and here, and so I can see that this function is going up like this and over like this. So this is a 2 and this is a 4. Remember, it's rise over run, so I got 2 over 4, or in other words 1/2, and that's going to be my slope. Now again, I don't know what my y-intercept is, but I don't have to. I can just use one of the points that we've just identified into this equation and figure it out. So let's identify, or let's write down what this point is. This point right here is going to be the point 14 on the x and 6 on the y. So this is the point 14 comma 6. Okay, just like that. And this is going to be our x sub 1, and this is going to be our y sub 1, right? And so we can plug that information into this equation. So we would get y minus my y sub 1, which is 6. So y minus y sub 1, which is 6, equals m, which we already said was going to be 2 over 4, or in other words 1/2, times x minus my x sub 1, which is 14. And honestly, guys, we don't need to change anything with this. We can leave this exactly like this. Okay, we can leave it exactly like this. We don't have to do anything else for this, for our writing of this expression. Now, we do, however, need to identify what part of this function we're talking about, and well, we're talking about right here, right? This part right here, we're going from 12 all the way over to 20, and this is the piece of this function that we're using in our piecewise function. So we need to specify that. So we're going to have it go from 12 is less than or equal to x, less than or equal to 20, because that's where we're ending. Right, and again, you could write that either way. We could have our bracket on the one side with 12 here and comma 20 parenthesis. Remember that the brackets are equal to, where the parentheses are not equal to. Right? Okay, let's just keep trucking through this. We got 2 more pieces. Our next one, this little black section right here, another horizontal line. Remember, when we do horizontal lines, all we got to do is specify the y value. What's our y value here? We're going 2, 4, 6, 8, 9 to get to that. So this is just going to be y equals 9. And that's all we need to put for the equation, right? We do, however, still need to specify that domain of this, or the part of it that we're using. And we're using what part? Well, this part right here, from 20 all the way over to 30. And we can, again, if this helps, you can trace it up like this, and you can see this is the section of that function that we're working with. So let's go ahead and put that in. I know it's going to be 20 is less than or equal to x is less than or equal to what did I say, 30. right? And we could put it in our other notation as well, whichever works for you guys, and that would just simply be bracket 20 comma 30 parenthesis. Okay, hopefully this is making some sense there, guys. And it's a gray area, by the way. I didn't actually put nice points here as to are they equal to or whatever else. So as a result, I'm just having one equation be equal to each point as we go through it. So just for that explanation. Okay. Now for our last piece, we got one piece left, and we should be able to finish this up and kind of move on with our explanation here. I've got this piece right here, this red piece. Obviously the largest piece of this whole thing, but we just, same process. Let's identify the key parts that we need to write this equation. Well, one, I need my slope, and two, I need a point, right? I either need that y-intercept or a point. So let's go ahead and work through this. So I can see that I've got a nice point. Does that seem like that's good right there? Yeah, nice point right here. And I'm not sure if that one lines up. Let's just go down to here, because you know what? I'm not 100% sure. So I'm going to do these two because I think that might work out the best. And so what that tells me is I just, track out my rise over run like so, right? And my rise here, I'm going down this time. So I'm going to have a negative number. And how far am I going down? Well, I'm going 2, 4, 6. So this is going to be a negative 6. And then over here, my run is going to be 20, right? And so rise over run, so I'm going to have negative 6 over 20, which we could simplify that fraction if we wanted to, right? Negative 6 over 20, I could pull out a 2 out of both, and I would have 3 over 10. Okay, hopefully that's making some sense. Hopefully that's making some sense to you guys. And let's just write that into our equation. So I'm going to have y equals, oops, not y equals, excuse me. We need to do this in the point slope form because we don't know our y-intercept. So now that we've done that, let's identify a point, and we can just use this point right here, which is positive 6 for the y and positive 40 for our x. So it's going to be 40 comma 6, and we can plug that in. So I'd have y minus y1, which is 6, and then that's going to be equal to 3 over 10 times my x minus my x1, which is 40. Like so. Okay, perfect. And that equation works just like that, right? The only thing we need to do now is just specify the part. Well, what part of this am I using? Well, I'm using from 30 all the way over here to 60, right? So we're going to have a bracket here and do our 30. Actually, not bracket. Let's do the other one first, sorry. I'm going to have 30 is less than or equal to x is less than or equal to, since it's our last one, we'll just do equal to 60. Right? And we could also write that in our other notation, which would just be bracket 30, comma, 60, bracket. Okay. Hopefully that's making sense, guys. So I know this looks like a lot of stuff here, but this is in a nutshell how we're going to express this function. If we called this function f of x, right? If we called this function f of x, we would write it out literally exactly like this. We might actually put this on the other side there, but I ran out of room. F of x equals these pieces right there. And I know that that's a lot. Hopefully this is making some sense to you guys. But just understand that, again, these are the Frankenstein of the mathematical world. We put these pieces of these different functions together to try and express what we're doing. And if you guys are unsure about when this would be useful, there's a lot of ways that this could be useful. And just to break this example down, we could talk about this in the sense from, say this is your miles from home, right? How far away you are from home. And then this could be our time here, right? And so if we look at this, we can see that in the space of 60, we could say time in minutes, right? So 60 minutes here, this could represent your time away. And so maybe what this is you were at home and you said, hey, you know what? I need to go to the post office, and I need to go to the grocery store and then come home. So you get in your car and you drive. And as you drive, we're going, however fast we're going. It doesn't really matter, but we're going, and in a space of 5 minutes, it takes me to get to the post office, which would be, if this was miles, that would be 5 miles away. So that's not bad, roughly 60 miles an hour, right? We get to the post office, and well, what's this right here? Why is that not changing? Well, that doesn't change because when you're at the post office, your distance from your home isn't changing. You're staying there while you're, packaging up your stuff and paying for postage and mailing and weighing it and mailing it off or whatever else, and then you finish that up, right? So from there, we can see that you were there for about 7 minutes, not too bad at the post office, right? And so then you get back into your car and you drive to the grocery store, right? And the grocery store now is another, how far away from the post office? Well, let's take a look, right? So the grocery store would be, we come across like this. So that's a 5 right there, and we come up to 9. So this is going to be a distance of 4. 4 miles from the post office. And how long did it take you to get there? Well, it took you, think about your distance across here, which would be 8 minutes, right? It took you 8 minutes. Maybe you're driving through traffic. Maybe you're hitting stoplights. I don't know. Maybe that's not a bad time, right? 4 miles in 8 minutes. It's 30 miles an hour, and if you're driving through town, that's probably about what you should be driving anyways, right? And then, well, what's this part right here? Well, we can see that we're not getting further away, right? We're not moving, getting a greater distance. This is our time here at the grocery store where we're staying stationary and going and doing our shopping. And then once we do that, we hop back in our car and we start driving home, which means that we're getting closer. And that's why we see this distance start to decrease as we approach home. I don't know. Why did it take longer to get home? Who knows? Maybe traffic was worse, right? You left your home. Say you left your home at like 4 o'clock. You start doing all this or something like that. But now it's 4:30 or closer to 5 or whatever, depending on when you left. And so traffic is just worse. People are getting off work and it's just busy, right? So it takes you longer. But these piecewise functions are really great for expressing a lot of scenarios just like that. And we can talk about one more, and I think we will, just for the sake of going through this, because I think that it's useful. Here's another piecewise function, and this piecewise function, guys, we could use to represent a variety of things, but I think for the sake of this one, let's talk about it in the sense of what's relative to you guys. A lot of you guys are starting to work now. You're getting paid different amounts and whatever else, and so this could represent your wages per week. So let's talk about this. If you feel confident with this material, guys, I'd say go ahead and just stop watching now. But if you want another practice on how we're going to do this, let's go ahead and go through this. So we could say that this is again your representation of the money that you make in a week, and say this is over the summer, and so you can work as many hours as you want. And so we're going to have on our x-axis here, this is going to be our time in hours, right? Our time in hours, and then this right here, our y, would be your money, what you're making, right? How much you've made. And so we could figure out, by the way, too, what you're making here just by doing a couple breakdowns. We've got here at $200. This is measuring your total, $400 there, right? And then let's break this down. So these are all going to be $50 increments, right? So that we can understand this. So this is $100 right here, and then this would be $300 right there, and $500 right there, right? Okay, so hopefully that's making sense. This is the money that you're making in a week as you work throughout your week, and so we can see right here that and then we're breaking this down too. So this is going to be 10 and 30, right, and 50. So just to start, let's identify how many hours did you work in a week. Well, it was a busy week for you apparently, because it looks like you worked 50 hours. And for those of you guys who don't understand what that means is that you get overtime. And overtime's a great thing. Why is overtime a great thing? Because you get time and a half. Okay? Which means you get paid 50% more for doing the same job. It's a pretty great place to be, right? So let's come up with our equations and let's figure this whole thing out. The first thing we want to say is what are we getting paid? And if you notice here, this is going to be our 50, and right here we've got 5 hours. So in 5 hours, you made $50, which means what are you getting paid per hour? Well, your salary here is $10 per hour, right? And or salary, your hourly wage, $10 per hour. Okay, so let's write our equation. The first thing that we want to start doing to write this equation is we're going to put our little f of x piece like this equals, and we'll put our bracket here. How many functions are we going to have for this? Well, we're going to have this function going along here, this blue one, and then we're going to have this orange one. So we're going to have two functions that are going to go into this piecewise function. So this one shouldn't be too bad. They're both linear, which means we're going to use that format y equals mx plus b, where our m again is the slope or rate of change, and our b value is the y-intercept. Okay, and also might be useful to use that other one, right? The y minus y1 equals m times x minus x1 for specifically the orange piece, because we don't see where that crosses the y-axis, right? We have to understand that to be able to do this, so we could use this one right there to help us with that. So our first equation, let's start working through that. Y equals, well, what's my slope? I'm going up 50 and going over 5. We just addressed that, right? So up 50, and then this is our 5 right there, which means my slope is rise over run, which is 5 or 50 over 5, which is 10, which we already identified that right there, right? We already knew that was going to be our rate of change, and the key thing that tells us it's a rate of change is that per. Whenever we have that, something that says, per this, we're usually talking about a rate of change. So our rate of change here is going to be 10 x, where our x represents the number of hours we've worked. Do we get any money if we haven't worked any time? No, that would be absurd. It would be absurd if you just expected to get money for not even showing up. So you don't start getting paid till you show up, which means there's not going to be any y-intercept, or our y-intercept is 0, right? Now, let's identify our parts here. We've got two different things here, so we need to, just like that Frankenstein example, what piece of this whole function, because remember, this function is going to go on forever, all the way in this direction forever, and going to kind of keep going like this forever. So what piece of this have we used? Well, we've used this piece right here from 0, right? From 0 all the way over to, all the way over to here. And that's where this function stops. So I can write this any way I want, but essentially, it's going to be 0 is less than x is less than 40. And that's just telling me that I'm using this function from 0 hours of labor all the way over to 40 hours of labor. Now, what happens after 40 hours of labor? We already said this. You get this glorious piece of information, or glorious time and a half right there, and that's it. That's great, guys, because let me tell you what that means. Instead of making $10 an hour, how much are you making? You are now making $15 per hour. Okay, nice place to be. That's not a bad wage there. And we can double check that, by the way, too, to make sure that our time and a half scale is correct on this by just measuring our rise over run. So I'm going up like this to there, and then over like this to there. This is going to be from 400 to 550, right? So that's going to be a distance of 150, and then we're going from here over to here, which is from 40 to 50, which is 10. So I'm going to have one rise over run, so 150 over 10, which is going to give me 15. So I know the start of my equation now is going to be, or I'm going to have my 15 dollars per hour. The next thing I want to say is, well, what's my y-intercept? Well, I don't know what that is, right? And that's where this function comes in super handy again. And let's just use a point from this function, and we can see a point right here, and that point is going to be 40 on my x for 40 hours and 400 on my y, meaning that you made $400 in 40 hours, and that's what this point right there represents. And we could use that in there as well. So let's plug that in. So I would have y minus y1, which is that 400, equals 15 times x minus x1, which is 40. Okay, and then again, we're not done. We need to limit that domain. And when are we using that? Well, we can see pretty clearly, we identified that a little bit already, from right here at 40 all the way to right here at 50. So we worked 50 hours total in the week, and we need to express that. So I would say 40 is less than or equal to x, and x is less than or equal to 50. So what this means is everything up to 40 hours is getting paid $10 an hour. But once you hit that 40 hours and 1 minute, right, or 1 second even, you are now getting paid, or no longer getting paid $10 an hour, but you're getting paid $15 an hour. And that's a good representation of when we can use these piecewise functions. And I guess for most of you, the more important question then is, how much money did we make in the week? Well, we can come over here and just take a look at where did this end? Our ending y value here is, just comes all the way back across over to here at, that's $550. So in 1 week, you could potentially make, $550 if you were doing some overtime, 10 hours of overtime and getting paid $10 per hour at your job. Okay. Great example of when piecewise functions are useful. Remember, guys, as we go through these couple key themes, we must identify our function. You can put it in a variety of forms, but we must identify our function, and then followed up with that, we must identify what part of that function we're using. Remember, we're not using the whole thing. Just like with this orange one, if we were still using the whole thing, this orange one would come out like this, right? And we're clearly not using that. We're only using just this little section right here. Okay, hopefully that makes sense, guys. If you have questions, comments, concerns, come and talk to me. Otherwise, good luck. Thanks, guys.